right. Welcome, everyone. Thanks for coming. I'm James Ward. I'm a developer evangelist at Heroku. I've been doing Java since like 97 and was at Adobe for a while doing Flex stuff, and now I'm at Heroku doing cloud stuff. So this presentation is going to be about something that I think is the future of how we'll build web applications. I think that we're going back to the model of client-server, just using the browser as our client. And so this presentation is going to be about how do we do that with Java and JavaScript and CoffeeScript and Twitter Bootstrap and those sorts of different tools. So there's going to be some live coding. We're going to talk about CDNs and cloud deployment. And so let's dive in. So first, let's talk a little bit about why are we going here? Why are we reinventing our web architecture again? And I think first we have to identify what is this new modern web architecture. I think there's really three key things that we're doing in the modern web architecture. First is that we're moving to a stateless web tier. So this means that we can much more easily scale up our web tier. Really, our web tiers are just becoming these stateless serialization tiers that just serialize data from backend data sources into most likely JSON or some other format, XML if you want, and apply security and transactions. And that's really what the web tier is turning into. And then for what we're doing with the actual UI of the application, that's moving to the client side. It's actually running on the client. Instead of just using the browser as a dumb rendering device that we just give it markup and then every user interaction goes back to the server to get more markup, that's like the old green screen model of doing things. And it definitely has its place in certain types of applications. For applications like Wikipedia, very content-centric, I wouldn't really advocate a different model. That one works well. But for interactive applications, things that have data and users need to do something in the application that's interactive, this is where I really see us moving to an actual client-server model where our client is the application. So then the third part of this is transparent real-time. Many of us have probably had the Google Docs experience where you get into Google Docs, you collaborate in real time with someone in a document. Now we're beginning to do that in the context of data. If you've ever seen the site Trello.com, it's a great project management site, and it uses this Google Docs way of transparent real-time so that your browser is always in sync with the changes on the server. And that means that as users are making changes, everyone is seeing those changes at the same time. And when you experience Trello, you're just like, yeah, that's how applications should work. It's weird that our applications in the web have always been out of sync from the server data. So I think that this is going to become a standard in the next few years, is that we will have these transparent real-time updates out to the client. So those are the three things that I'm going to be diving into today. But let's talk about why. So we've got these three different things that are changing in our web architecture, but why are these things changing? One of the big ones, I think, is performance. There's a couple different facets of this. One is server-side performance. If we're constantly going back to the server for every interaction that the user needs to do, that's a lot of unnecessary loops for things that could just happen on the client. I think Ajax and that whole revolution got us kind of part of the way to there with partial page refresh. But by moving the whole entire UI of the client out to the client side, we can do much more, and we can have much lower latency in every interaction that you have in the UI. So, and then faster development iterations is another big one. So usually today when we build a standard web application, we're doing a lot of our coding on the server. Our cycles can be very long because as we make changes, we're changing potentially back-end logic, UI logic, kind of all at the same time. And we're working in usually one code base for both sides of the wire. So now what we're beginning to do is actually split out our client side from our server side into two distinct pieces, which means that actually two different teams can iterate in parallel on the client side and on the server side, and the connection between the two is RESTful interfaces, which we'll talk about later. So that faster development iterations is a big thing as well. And then the last one is reusability of code across web applications, across mobile applications. Things like PhoneGap enable us to take the JavaScript and CSS that we write for our web applications and reuse that for our mobile applications and package them as actually installable applications. So that reuse between web and installed applications with PhoneGap or potentially mobile applications just in the browser as well, I think that's another huge benefit of this model. So let's talk a little bit more, dive into some of these details a little bit more. So the Stateless Web Tier. The big thing that this brings us is server affinity, meaning that a server can come up, a server can go down. It doesn't matter because we're not storing state on each individual server. And so what this really enables us to do is to do upgrades without the pain that a lot of us experience when we have stateful web tiers. You know, you hear stories, maybe you have experienced this yourself, where when you do an upgrade, you actually have to tell your load balancer to keep the users who have open sessions going to the old version of the server, and then wait until all those sessions die before you can actually move everyone to the new version of your system. That is not continuous delivery. That is not continuous deployment. It's really a barrier to how quickly we can ship updates to our software. We want to get to the GitHub model where, maybe not that extreme, but GitHub releases to production like 20 times a day. How many of us, are anywhere even close to that, right? So we'd like to be at least a little bit closer to that. And one of the big barriers that a lot of us have in getting there is the state that lives in our web tier. So then another thing great about Stateless Web Tier is that we can much more easily support browser back, browser reload, browser forward. Those are metaphors in browsers that are not going away, and so we do have to make sure that our web applications support those metaphors well. Okay, so now about client-server web and mobile apps. So what I think we're moving to is an architecture where our web tier is really just RESTful JSON services, and that's it. We'll talk about that in a little bit. And then our client tier is JavaScript, CSS, and just HTML. The thing that I'm going to talk about at the end, which I think is really interesting about this model, is that once we've built the client side of our application with a bunch of static assets, JavaScript, HTML, and CSS, and images, we can actually take that whole part of our application and edge cache it onto a CDN. I'm going to talk more about this later, but I think this is where things get really interesting. It's really hard to geolocate, geodistribute data. Moving data across the world and keeping it in sync is a very, very hard problem to solve. But taking static assets and putting those all over the world so that everyone has a copy of those static assets close to them to reduce latency, that's something that is actually very easy to do and can really increase the performance and the experience that users have with our applications. So I'm going to show you that in a little bit. And then transparent real-time, I've talked a little bit about this, but this is really just becoming things like instant notifications out to the client, and now the instant data instant data updates are just becoming normal. There are some scalability potential concerns here. I think PlayTo and a lot of the new Scala web frameworks do a really good job of addressing this. They're built on Netty, which is NIO-based, so they can handle the scalability much better than the traditional frameworks. WebSockets, that's a potential place to enable this better, but that's something that requires modern browsers. And so until the point when we have WebSockets readily available on everyone's browser, we're going to have to do things like Comet, long polling, and other techniques like that. Okay, so what is HTML5? This is, it was in the title of my talk. We've got to talk about HTML5. Here's the definition from Wikipedia of what HTML5 is. My definition of HTML5 is that the browser is now an application platform. Now we can actually build and deploy applications that use browser technologies for the client side of the application. So that's really the way that I look at HTML5. A lot of people talk about HTML5. Usually when they're referring to HTML5, they're not referring to all the specifications that are technically part of HTML5. They're probably not even referring to the new tags and new APIs that are available in HTML5. Probably what they're talking about is building applications that run in the client side, run on the client side in the browser. So there is a bunch of new stuff in HTML5, video tags and new HTML tags for declaring what your content structure is. There's new APIs. There's CSS3. But I think the most important thing that kind of gets lumped into HTML5, which has nothing to do with specifications, it's just kind of happened with browser modernization, is that the JavaScript engines have gotten a whole lot faster. And that's really what is enabling us to move to this new architecture of client-server in the browser. We really needed JavaScript to get faster in order for us to be able to build large applications in JavaScript. So that's not part of the spec. There's no spec that says, hey, faster JavaScript, right? It just has happened because us web developers have pushed on the browsers and said, make these JavaScript engines faster. And now that they're faster, we can do a lot more with them. Okay, so HTML5 really just is modern web apps for most of our sakes. If you're doing mobile app development, this is probably different, right? There are HTML5 APIs on mobile devices that you can reliably use. Most of those mobile devices that people have, if you're building apps for iPhones, the HTML5 APIs are going to be a lot more consistent there than it will be on just the broad masses desktop or laptop machines. So if you're doing mobile development, you probably can start to actually take advantage of some real HTML5 technologies, especially if you're using things like PhoneGap. But for most of us building just standard in-browser web apps, HTML5 just means modern web apps. So there's a whole bunch of tools that are evolving in this space to support our development of building these types of applications. jQuery has been around for a long time. As a Java developer, I just started learning jQuery like 9 months ago, and it's fantastic. It makes doing browser JavaScript development actually palatable. It's really become the standard library for the browser. So if you are getting into this world of building client-server apps in the browser in JavaScript, you have to know jQuery. It's just central to everything that's happening right now. Twitter Bootstrap is kind of newer on the scene. For me, when I was in the Flex world, the thing that was great about Flex was how easy it was for developers to create decent-looking UIs. And the same is true now with Twitter Bootstrap. With Twitter Bootstrap, I don't have to be a real CSS expert. I don't even have to know a whole lot of HTML in order to create decent-looking UIs. So for me, I've really enjoyed using Bootstrap. It's very easy to learn. Really, all that it is a bunch of CSS and JavaScript libraries, components that really make your applications look good. CoffeeScript, this is the kind of new hipster technology in the JavaScript world. It's a better way to write JavaScript. It compiles into JavaScript, so I wouldn't recommend you jumping into CoffeeScript unless you have an understanding of JavaScript. Just because when things go wrong, things don't work as expected, you kind of have to know what's underneath the covers. You have to know why the CoffeeScript is getting generated into the JavaScript and what the JavaScript is actually doing. Also, today, as far as I know, there's no debuggers for CoffeeScript. So if you do want to walk through your code in the browser, step through it, you're going to be doing that in the JavaScript, not in the CoffeeScript. So maybe there's new tools that will come up that address that. But CoffeeScript, I'm going to show it to you today. It's cool. It's the new hipster thing. It cleans up a lot of the nastiness of JavaScript. But for now, this is the kind of world that we live in the browser. We're not going to have a better option than JavaScript as our actual language that we run in the browser for a long time. To get a new language out there, to get it adopted by all the browser manufacturers, to get it adopted by all the consumers out there, it's going to take a very long time to supplant JavaScript. I hope that someday it happens, but it's a long ways away. So for today, we have JavaScript, and then we have things that generate JavaScript, and so CoffeeScript is a great option for that. The next big thing that's happening in this space is asset compilers. I've not experienced the Rails one, but I have used the PlayTo one, and you'll see that in a little bit. What an asset compiler does is it brings together the development spectrum for a typical server-side development tool where you're writing your REST services or using server-side templates. It brings that together with client-side development. Meaning that in the same project, I'll be developing my client side of my application, and my client side will be running through compilers and syntax checkers to help me as I'm developing both sides of the application. So this is something that I think will really help move us forward. You can do this in like 2 separate projects if you wanted to, but the way that I've been doing it is just in one project, and we'll see that in a little bit. So then the next place where there's a ton of stuff happening is in MVC frameworks. We are reinventing all the web frameworks that we've had in Java for a long time in JavaScript on the client side. So it's happening now. There are tons of options out there. Backbone seems to be the most popular right now. That's purely just based on what I see out there. But I would recommend don't just pick Backbone because it's possibly the most popular. Check out a number of them. You may find that Angular just fits better with how you want to write code. So there's a lot of different options. Check them out. And then, like MVC frameworks are moving from the server side to the client side, templating is also moving from the server side to the client side. So we're going from JSPs and Play has Scala templates and had Groovy templates. We're going from that to actually writing those templates on the client side and running them through JavaScript to actually use the templates. So there's a lot of different options here as well. Again, same thing as the MVC frameworks. There are some kind of forefront leaders in this space, but check out a bunch of them and see what fits with you. There's been some great blog posts that have compared the different templating engines out there, the client-side templating engines. So read through those, see what connects with the way that you want to write code, the way that's familiar to you about writing code. So that's kind of what's kind of happening, the different tools that are cropping up in this space. This change is happening so quickly in this space. There's a new MVC framework every day. So it's going to be tumultuous for a couple years. I think that it's going to take a couple years for this space to really coalesce around the right ideas, the right solutions, the right libraries. And a few years down the road, I think we'll see a lot more maturity in this space. Right now, I think this space is mostly very, very immature, especially coming from people that have been doing Java for a long time. An example of this that I'll talk about later is that most people today, if they want to use a library in JavaScript or a CSS library, you just go download the CSS file, download the JavaScript file, and put it into your source tree. That's kind of what I did with jar files a long time ago, and so I think we need to change that. I think we need to actually declare and manage our dependencies for our client side as well, and I'll talk about that in a little bit. Okay, so let's talk about REST. REST, if you're not familiar with it, it is a way to define access to your back-end data, essentially. And so we use the HTTP verbs to do this. The HTTP verbs and paths. So we say verb get means that I'm going to get some data. A verb post, if you're doing a post to /widget, that means I'm going to create a new widget. If I do a HTTP put, that means I'm going to update an existing widget. Delete, the HTTP verb delete means I'm actually going to delete the widget. So we're actually trying to really use the HTTP protocol instead of just being limited to get and post like most of us have been for a long time. HTTP was created with other things in mind, more beyond just get and post. So we're really using the verbs to describe what we want to actually do with that backend data. So we'll see an example of that in a little bit. I think that the world has really decided that JSON for now is the serialization standard. It's so well supported in every language, everywhere, that it really has become just the standard. So what most people are doing now is building REST services that talk JSON. You can still do XML if you want to, but I think that it's just a bit more challenging. So JSON seems to be the new way that most people are doing it. Maybe not new. Okay, so jQuery, quick little thing, we'll see more of this in a little bit, but if you want to do a jQuery XML HTTP request to get a widget, what that looks like is $.get, so you're calling the get function in the jQuery library. The jQuery library is abbreviated with a $. You can also just call jQuery, spell it out. So and then there's a lot of callback function use in JavaScript as well. The same code in CoffeeScript looks pretty similar. It's less verbose. It uses space. Space is significant in CoffeeScript, so I need to actually use indentation. I personally love that. I am really anal about how I space my code anyways, so it works well for me. Okay. So let's see an actual example of this type of architecture. So I'm going to build an app from scratch, and I'm going to use PlayTo to do this. So let me just do play new and call this app foobar, and give it a name, and I'm going to specify to use Java. It's been a really great development experience for me for building REST services that have CoffeeScript front ends and JavaScript front ends. So the asset compiler, I'm not sure why it plays. I think it's going out to the network or something. So the asset compiler in PlayTo, what it does is it will take my JavaScript, my CoffeeScript, and my less and run it through this syntax checker and compiler to compile CoffeeScript to JavaScript. It'll do auto minification and stuff for me. So we'll see that in just a minute. Okay, let's go open up my project. Oh, before I do that, let me go start up my Play server. And now we'll go into IntelliJ and create a new project. And we'll do it from scratch. I'm going to call this one foobar. And then open up the module here in a second. Let's go import that module. And there it is. Okay. So this will be my PlayTo project here inside of IntelliJ. And I'm going to walk you through the structure of that real quick, just so you can get an idea of PlayTo and how it's structured. But let's pull up the server. So there we go. There's my Play app now up and running locally. This is just the default page. So let me show you how this page actually gets rendered in Play. So first we'll start with the routes file. This is in conf routes. We'll see that there's a get handler for requests to slash, and then those get handled by the application controller and the index method on that controller. So let's go take a look at that controller here. So here's that application controller. You can see the index method. It returns a result. And then what we're doing is calling a template. I'll show you that in a second, and passing that template a string. Let's just change the string so you can see how that works. So I'm just going to change that and save it, and then come to my browser and hit refresh, and it will automatically recompile that, and now you see my string there up in the header of that page. Whoop, let's go back. So this is really a huge benefit in Play is I just go to my browser and hit refresh. There's also a way you can do it whenever the files change to get it to recompile. And so this makes the development experience very smooth. For any routes, any configuration, any Java code I change, any Scala templates I change, any JavaScript, CoffeeScript, or less that I change, all of that gets recompiled just by hitting refresh or when the files change if you want to run it in that mode. So very nice. And then let's go check out the template here. So this is rendering the index template. This template takes a parameter of message string, and then it's using the main template to pull in, we'll see here, pull in just a basic HTML page that it's using, and that's it. So let's make a quick little change to this page. Let's do an H1 and put in here the message that's getting sent into this template, so you can see how this works. So we'll just refresh. And there we go. We see our hello world there on the page now. So it's recompiling all this stuff just on the fly. Okay, so that's how the basics of Play work. I want to now add a REST service to this, or add a service to this project. Add a model first, and then add a service, and use that service just so you can get an idea of what the development experience is like as we head down this path of doing client-server in the browser. So first, let's create a new Java class, and this is going to be called models package, and then I'm going to call it bar. I'm going to create an app that just stores a list of my favorite bars. So we'll we'll annotate this with the @entity, and whoops, got to actually extend something. We're going to extend model. That's going to be the eBean model class. And then this thing has an ID, primary key, and we'll make that a public string ID. And then we'll put on here a string for the name of my favorite bars. Okay, so that's my model. To configure the database stuff in Play, we just come into the comp file here, and I'm going to use an in-memory database when I'm running locally, and tell eBean where to find those model classes. But now, if we go back and hit refresh in the browser, we'll see that Play's telling us, hey, you need to do a database evolution to upgrade your schema. That's great. We'll apply that evolution, and now we're good. So now we need some way to create new bars. I'm going to do this in the traditional way with just like a standard form, and then I'm going to do JSON and CoffeeScript and jQuery to pull the bars out. So first we'll start with just kind of traditional way of doing this. So first, start in the routes file, and we'll create a new handler here for post to/add bar, and then we're going to call controllers.application.add bar. Now let's go over and create that method. So let's go add in a new public static result, and this one is add bar. And what I'm going to do is, Play has this way to map the request parameters to a value object. So I'm going to get my bar from, let's import that bar. I'm going to import it from, I need to create a new form. So I do form of bar.class. And then I'm going to tell it to bind from request. So bind the request parameters into this form. And then I don't want the form, I actually want the bar. So then I just call get on that. And now I get my bar populated with the request parameters that we'll send it in a second. Now to save that bar, I just call bar.save because I extended model, get the save method. And now on a successful add bar, I just want to redirect back to the index page. So I'm going to return a redirect. And the way that I get the URL to the redirect is that Play has a reverse routing system. So it sets up a reverse routing table. So the way that I access that is routes.application.index. That will give me my reverse route back to the index. So I'm redirecting back to the index. Okay, so we've got that part of it. Now let's real quickly go add in a form here onto our page. So I'm going to do a form. The action is going to be, I'm going to call routes.assets, routes.application.index, add bar. There we go. And then it's going to be a method post. Okay, and then this will have an input here, name of name. That's going to match the parameter on my bar. So that's how we map from the name coming in from the request to the name parameter on my bar object. And then let's go add in an input type submit. And let's go test it out. Okay, so let's just refresh in our browser. And hopefully we'll get a form that we can add new bars with. So there we go. Let's go add a new bar, and looks like it worked. It redirected back to the index page, no error, so that's a good thing. So we've added bars, and this is, again, very traditional way of doing web applications with server-side templating. But now I want to show you the next generation of how we're going to do it with doing the get of these list of bars and rendering them on the web page using CoffeeScript and jQuery. So let's come in here and add in a new route. So we'll do a get handler for /list bars, and we'll call controllers.application.list bars, and then go in and add that method. So public static result list bars. And now what I need to do is fetch my bars from the database. So to do that, eBean has some nice finders in it. So I'm going to create a list of bar here. And let's import list. There we go. Bars. And now I'm going to do a new model.finder. And IntelliJ thinks it's real smart and kind of screws up this one. So let's fix that. Okay, now I'm going to tell it the primary key type is string.class, and then the actual entity type is bar.class. And then on here I can just call all. That will fetch all my bars. And now to take these bars and output them as JSON, I want to return a OK. So I'm going to say OK, status code 200, OK. And I'm going to convert that list of bars to JSON. So I just call this nice toJSON method. We'll import that in a second and pass it the bars. So let's go import toJSON. It's a static import. There we go. And now let's actually test it out. Let's go in the browser to /list bars. And if I did everything correctly, hopefully we will see a JSON serialized list of bars in just a second. There we go. Okay. So there, yeah, cool. So a few lines of code, we're able to get our data converted to JSON. Pretty easy, pretty cool. Okay, so now next step is to consume this JSON on the client side. So when this page loads, I want to make a request to that list bars service, get the JSON, and then render it in the page. So to do that, just a couple more lines of code here. In my page, I'm going to have a place to put those bars. So I'm going to add a UL, give it an ID of bars. And then I'm also going to do a script tag here that will load in my CoffeeScript that's compiled into JavaScript. So to do that, let's go, actually, before we fill the rest of that in, let's go in here and actually create that CoffeeScript that's going to do that. So this is where I'm going to use the asset compilers. Actually, in my source directory here, I'm going to create, first, let's do a new package here called assets.javascripts. And so that's my package for my compiled assets, whether they're JavaScript or CoffeeScript. And now I'm going to create a new file, and this is going to be called index.coffee. Okay, so now let's write some CoffeeScript. This is going to be pretty simple. First thing is I want a ready handler function call. So when the page is up and ready and ready to go, I want to call a function. So that's how we do that with CoffeeScript and jQuery. And then I want to make my GET request to that list bars URL. Play has a nice way to take the reverse routing stuff and pull it into JavaScript, and I could do that, just be a few more lines of code, but I'll just go with the string URL there. And so this get needs a function handler that it's going to call once it's got the deserialized JSON back from the server. So this is going to be a function that has a parameter of bars, so that's where I'm going to put that deserialized data. And so I've got my bars, and that's my function handler. So now I want to iterate through my list of bars, and for each bar I want to add it to that UL that I defined on the page. So to do that, I'm going to do a jQuery each. That's like a for each. I'm going to tell it to iterate on bars, and then for each bar it's going to call a function. The method signature of the function is an index and an item. So we'll put in those parameters, index, and my item I'll just call bar. And then that's my function that we're going to call on each of those. And now I'm going to use jQuery to find that UL, find that unordered list in the page. So to do that, I'm going to say, all right, find the thing that has an ID of bars, and then append onto that a new thing. So the way that I create a new thing in jQuery is I'm going to create a new list item. And then I'm going to set the text property on that item to bar.name. Okay? So that's my CoffeeScript. Fetch the bars, iterate through the bars, and add each one to this unordered list on the page. Okay? So now let's go back to my web page here. And now I can specify what source, where to get this source from. So I say source equals, and now I can say, all right, get me the routes assets at, and now pull in the asset that's in the JavaScript's index.min.js. And you may be thinking, all right, where does that index.min.js come from? Well, Play knows that because I've named my CoffeeScript file index.coffee, and I'm asking for a minified version of that compiled JavaScript class, it knows to compile the CoffeeScript into JavaScript and then minify the JavaScript. Okay? So let's finish closing that and save it. And now, if that's all good, let's go hit refresh. And so once this page loads, did I have a coding error? Oh, double quotes? No, that should be okay. Oh, in my coffee script. Thank you. It's the pair programming is fantastic. Ah, there it is. Pair programming with 100 people is awesome. Awesome, there it goes. Thank you for the help. Thanks. Okay, so my favorite bar, actually, this is supposed to be bars, is called My Brother's Bar. So let's add that one. So you see that what's happening is when this page loads, it's making that jQuery GET request through XML HTTP request. So it's not doing a page refresh to get that. It's doing it, behind the scenes, getting the JSON from Play, and then pulling it in, deserializing that JSON into objects, iterating through the array of bars, adding each one to the UL. Okay, so that's just a really simple example to show you the very, very basics of where we're going with all this. Obviously, the next step to this is to take what I've just done and break it out into MVC pieces on the client side and add add client-side templating to this as well, so that I'm not, doing some of this nasty kind of jQuery stuff that I'm doing here. But hopefully that gives you an idea of the start of where this is all heading. Obviously, the next step to this is to take what I've just done and break it out into MVC pieces on the client side and add client-side templating to this as well, so that I'm not, doing some of this nasty kind of jQuery stuff that I'm doing here. But hopefully that gives you an idea of the start of where this is all heading. Okay, let's jump back to the slides. If you want the code for this, it's on GitHub, on my GitHub, PlayTo-Java. If you want to see the Scala version, PlayTo-Scala. Okay, so now let's talk about Twitter Bootstrap. Twitter Bootstrap, as I said, is a way for developers to easily make our web pages look a lot better. So let's take this a step further and now pull Bootstrap into this application and make this look a little bit sexier. So to do that, what I've done, actually let me show you one slide real quick. Last night I was talking with the Play guys and I was like, all right, we got to deal with this like managed dependencies thing in the web world. So they helped me. We came up with a way. It's very simple. We just put these web libraries, whether they're CSS or JavaScript, we put them inside of jar files. And it turns out that Play2 already has support to pull static assets out of jar files. So all I had to do is create a Maven repository with some jar files in it. And now we can pull these jar files down as dependencies. So this is called Webjars. It's on GitHub. Other ones. Right now it's just Bootstrap and jQuery. So if I wanted to, by default, my jQuery is getting pulled in as a static asset in my source tree. I could actually delete this out and specify jQuery as a dependency. I'm going to not do that right now to save time. But let's actually go in and at least do the Bootstrap part of this. So first, right now, I need to add my Maven repository to the list of repositories here. So I do resolvers plus equals, and then give it a name. We'll call it Webjars. And then I'm going to give it, ooh, thank you, intelligent, go away. Okay, and then I give it the URL to my Maven repository, so that's webjars.github.com/m2. And then I need to specify my dependency here. So my dependency for Bootstrap is, let's see, it's com.github.twitter, and then the name is Bootstrap, and then the current version is 2.0.2. Okay. So now to get Play to pull these dependencies down, let's restart it real quick here. I think there might be another way to do this without restarting it, but as far as I know, it's the only time I ever have to restart Play is when I change its dependencies. So now it's going to hopefully resolve those dependencies, pull them down from that Maven repository, and it looks like we're good. Okay. So now I want to use Bootstrap in my page. So to do that, let's go into my kind of base HTML page here. And right now there's a main.css there. I'm not going to use main.css, so I'm just going to replace this with bootstrap.min.css. So that bootstrap.min.css is actually coming from my jar file that I just pulled down from that Maven repo. Okay, so I've specified that as a dependency. I'm using a specific version, and I'm much happier about my managed web dependencies now. Okay, so I'm pulling in Bootstrap. That's great. Now let's actually use Bootstrap. So to use Bootstrap, there's a little bit of kind of verbose HTML. So I've got this already ahead of time. Bootstrap.text. Okay, here's my HTML. It's just the way that they do this is all through CSS classes. So I just need some divs with some classes in them. So let's go in here and add in that stuff. Okay, and copy my body of my page into this container. So real quickly, Bootstrap, it's using these classes, navbar, navbar fixed top, navbar inner, container fluid. It's got lots of different classes that you can use to do layout of your page, to do make things look great, whatever. Okay, so then I also need to do one other quick thing in here is I need to set, whoops, not on there. On here, I need to set the style. I need to give it a margin. So let's do margin top, and we'll do 60 pixels. Okay, so that'll just make sure that this thing moves down the right amount. Okay, let's go back to our browser and hit refresh, and hopefully now we'll have the Twitter Bootstrap. Oh, we need to apply our evolutions because we restarted our server and lost our in-memory database, but there we go. Now here is our new sexier version of my app using Twitter Bootstrap. So obviously not like super sexy yet. There's a whole lot more we can do with Bootstrap to make things look really great, but that's how you get started using Bootstrap. Okay? Okay, so now we've got Bootstrap in there. We're using Bootstrap as a managed dependency. We're happy about that. So the next thing I want to do is, all right, I've got my application. I want to deploy it on the cloud. So I work for Heroku. I like to deploy my Play apps on Heroku. So to do that, we need to do a couple things. One is that we need to define a proc file. And a proc file tells Heroku what process to run on the system. And I'm also in this proc file going to override some of the default configuration because Heroku is going to give me just a basic Postgres database. And so instead of using the in-memory database, which is my default currently, I want to use the Postgres database when I run up on the cloud. So I need to override those things, those different options. And then I also need to specify the Postgres driver as a dependency in my application. And then I'll push it. And then I'll push it up to Heroku. So first, let's go and add in our Postgres dependency. So let's do PostgreSQL and PostgreSQL. And then the version 9.0-801-JDBC3. Okay. I've never typed that before. That just came out of nowhere. Just kidding. Type that all the time. Okay. So that's my Postgres, and then I need my proc file. So let's go copy. I've got a proc file already set up. I'm just going to copy it in, and then I'll show it to you. So let's copy that there, and let's go check it out. So here is my proc file. So the proc file says run, for the web process on Heroku, run target/start. That's the process to start up the Play server when you build your Play application with SBT, which is what Heroku is going to do. And then I'm telling it which port to bind to based on an environment variable, telling it to automatically apply my database evolutions using the Postgres driver, and then setting the database URL to the environment variable that Heroku's given me for my Postgres database. Okay, so that's it. So we've got our application. Let's go deploy it on the cloud. So to do that, Heroku uses Git as the way to transfer files to and from Heroku. So I need to create a new Git repository. And then I'm going to add my files to the Git repository and then commit them. And now that they're all committed, I'm going to tell Heroku to create a new application for me. So one way to do that is with the command line. Say, Heroku, create a new application on the Cedar stack. Cedar is the third generation of Heroku that supports Java, Scala, Clojure, Node.js, Python, all that good stuff. So hopefully if my network cooperates, let's go make sure the network is still running, then we should get an application created. Okay, cool. So it automatically allocates a name to my application. I got strongleaf 8630. And so now this has an endpoint available on the cloud. It also has a get endpoint, which is where I'll push my code to. The client is also added that get remote automatically to my Git configuration. So now I just need to do git push Heroku master. So that's saying push this application to Heroku. And then Heroku will run the SBT build on this project and then create the executable version of my application, deploy it out onto what we call a dyno. Dynos are the place where these applications run. They're kind of like virtual servers. We don't call them virtual servers because you don't have to manage them. We manage them. You, as developers, get one dyno for free every month for each application you create, so it's easy to get started. Okay, so the SBT build, it takes a little bit to run. SBT's got to pull down a lot of. So while that SBT build is running, the long run is the first one. Once we pull the dependencies down, then the next ones are faster. But while that's running, let's talk about the next fun thing, which is the next step of this, what we're trying to do here with client server, is to take the client side and move it onto a CDN. The reason why we want to do that is that our typical web applications look like this. We've got our web application. Most of the HTML and content coming from the application is essentially dynamic. This is today. Very little of it is static assets usually. So usually we centrally locate this application into one geographic area. And what that means is that people that are close to that geographic area, their requests for static content and for dynamic content are going to be pretty quick. Let's say 200 milliseconds. But somebody who's geographically further from that location, they're going to have much higher latency for each of their requests, whether it's for static content or for dynamic content. So the model that I think we're moving towards is to take our services that are just serving JSON, which are a much smaller percentage of our overall number of requests and size of requests, the amount of data that's being transferred, keep that geographically central to some place. The reason for that is, again, geo-distributing data, it's a very, very hard problem. If you do want to do it, great. You can even make that part of the picture better. But the much easier thing to do is, now that you've gone to this client-server architecture, you take your entire client side, which is all these static assets, HTML, JavaScript, CSS, everything, and you edge cache that all around the world so that everyone has low latency getting to the client-side assets for your application. So the good thing is that there's a number of different ways to do this that are very, very easy. So I've implemented one of them here on this little app that I started building a while ago called tryit.herokuapp.com. This app is built in this architecture that I've just been talking about. That when I rendered that page, the actual page had essentially nothing special coming from the server. Then it pulled in all the static assets for Bootstrap, for my jQuery library, my own JavaScript code, and then it did a JSON request to get the tags, did a JSON request to get the information, and then using jQuery, I laid everything out. Okay, so also we can do cool things with the HTML5 history API. When I click on one of these items, that didn't do a page refresh, but it changed the URL to something sensible without any hash bangs or any of that stuff. If you can read that, there's no hash bangs. It changed the URL without doing a page refresh. It just did one very small GET request for JSON data to get the data that it needed to render here, and then use jQuery to render that. So pretty simple application that I built with Play and Bootstrap and jQuery. But here's the cool thing about this application is, let's open up Firebug here, and let's just reload this page. So if you can see, the font's kind of small, but what you'll see is that I made an initial request to kind of get the page, the base page of my application. This one went to Heroku. So this one, the base page that just pulls in, kind of bootstraps everything in the application, that one went to Heroku. But then you see all these requests that are happening in parallel and happening very fast are going to the Amazon CloudFront CDN. So I've taken all of my assets and it said, all right, go pull those from the CDN. And what's cool about CloudFront is you can actually tell CloudFront to if a request comes in for a static asset and CloudFront doesn't have it, then it will actually go to your origin server, come back to my application on Heroku to get it, and then if I've got my HTTP header set correctly, then it will edge cache that content automatically. I don't even have to think about it. So that's what I'm doing here. You'll see there's a bunch of static content coming in from CloudFront, all correctly being cached. And then you'll see 2 very small requests for JSON data coming in here as well. Those are going back to my application on Heroku. So this is the manifestation of really where I think we're going, is to build our client side, all the JavaScript and CSS and stuff you see there, build that all out, build our entire client side in those technologies, edge cache it so it all loads very, very quickly, no matter where you are in the world, and then just talk JSON back to the server. Okay? So let's go see how our deploy is doing. There it is. Okay, so we've got our little Play app running on Heroku. Let's go check it out. So I've got my strong leaf 8630, and there it is running on the cloud. So there we go. That's the Play app running on Heroku. Pretty simple. So now let's talk a little bit about real time. We got a few minutes left. So as I mentioned, I think real time is the other big part of this. PlayTo does a really good job of handling these real-time applications that are updating very quickly. There's a couple different models you can go with for this. Comet is one. You can optionally use Akka actors behind them. The reason why they can do this so high performance is that they're building on top of Netty, which is NIO based. And the big benefit to that is that the typical servlet request, it takes a thread per connection. So in your typical Tomcat server, if you're making HTTP servlet requests back to it, let's say you have 250 threads allocated to Tomcat, that means that you can have 250 open connections back to the server. The way that Comet works is in order to push data down to the client, it keeps these connections open. And so what that would mean in a typical Tomcat scenario is that on each server you can get like 250 concurrent users connected to your app. That's not scalable. So the way that Netty does it is because it's using NIO, it actually can take the threads that are handling an HTTP connection, and when it's essentially idle, when the connection is not in use, Netty can actually take that thread back, reallocate it to someone else, and then as soon as Play or whoever says, all right, I need to send something to the client, then it gives the thread back to the HTTP process and says, all right, now let's send some more data down to that client. So this is how they can scale up much more massively. It's done through a few different APIs. You can use Comet, you can use WebSockets, you can use asynchronous callbacks. So different ways to do it. But check it out. They've got some great examples in Play. If you go in and look at like Comet Clock or the chat example that uses WebSockets, you can get a good idea for how that's working. Here's a quick little example of code snippet for the Comet stuff. Very easy to set up. You just return a OK, and then inside that OK you do a new Comet. You're going to tell it what you want the actual like JavaScript call to be, which is parent.clockChanged. Comet works by using an iframe that just constantly is receiving from the server, and then we send script tags from the server down to that iframe, and then those script tags are calling some callback back in the main page. So in this case, that callback is the parent.clockChanged JavaScript function. So pretty simple. In this case, we'd of course have some like Akka process or some other process somewhere that is feeding information when it wants to down to the client. If you have like a messaging system, you can hook this up to a messaging system. So on a message, you take the message out of the queue, send it down to the client, that kind of stuff. So very simple with PlayTo. Okay, that's it. We have 3 minutes left. Is there any questions about anything? Went through a lot of information. Hopefully not too overwhelming. Okay. Questions? Okay, I'll show you since I've got more time. So if you go to github.com, I'm pretty proud of this Webjars thing, so I'm going to spend a minute talking about this unless there are questions. So go to github.com/webjars. So right now you'll see that there is my jQuery jar, my Bootstrap jar, and then my Maven repository site, which is available at webjars.github.com/m2. And so real quick, how this works, jQuery.jar, I have a Maven build that's going to build the jar, and then I put jQuery here in my source main resources public JavaScript directory, and I put in both the minified and the non-minified, and took the version out because I'm already specifying the version in the dependency. So I just did this last night. Would love feedback on this. I would love contribution. I think that we really need to start managing our client-side dependencies and not do like we did with Java for a long time and put jar files into directories. Okay, so wanted to spend a minute talking about that. Any questions about anything? Okay, is everybody going to build? Yeah, question in the back. Sorry, I can't hear you. Of what is it? Dart. The fact that Josh Block is now on the team gives me some hope for it, but I think that we're a long ways from being able to have an alternative to JavaScript just because it takes so many players who have much different goals working together to do something like this. I think maybe 10 years down the road we could all be using Dart in the browser. That'd be great. Right now we've got JavaScript. If you're going to be doing any kind of Java web development in the next like 5 years, you're most likely going to be using JavaScript unless I get really surprised by something else happening. But learn JavaScript, and then learn CoffeeScript or potentially like ClojureScript or something on top of it. Yep. Sorry, what is it? GWT. I have not used GWT that much, so I don't know. I don't have a great opinion on it. I like this model. I come from the Java world, and I like writing JavaScript. I like writing. I was a JavaScript hater for a long time. I actually like it. I like that I am directly controlling what's going on in my browser. So I like this model. I like not being so far abstracted from what's actually happening. But that's probably just personal preference. So if you want to write Java that generates JavaScript, then GWT would be a great option. Okay, we're out of time. Thank you so much. Hope it was useful.